in the desktop, you can convert it into a directory. And next, you can also have the version control also. So that is the functionality of Git. Say, for example, every time you can maintain the versions and commit and push that type of functions also you can use it, so that your latest version will always be available in the repository, which you can share them with your users. Or a package or a Shiny app. So, and Shiny app, what I told you, the Shiny app is only for dashboards. Suppose you have developed a sales model, what you do. So if you input all your details, then it will be predicting the sales. Then this dashboard, what it does, this is where it will be, say, for example, we have seen that golf play. So in golf play, this is outlook, and next temperature, humidity, and wind, and everything, whether it has to predict whether play yes or no. Then I can use it as a dashboard. Then I will say that today the temperature is so much, the forecast is here, and next it is sunny, or that type of thing. Finally, what will be the predicting probability whether we can play or we cannot play. We will postpone it. Whether the flight is yes or no. So this environment is called the dashboard environment, or this is also called, it is a web app, and you need not run in your local system. You can run it only in the cloud. Next, you can create my name directory, start a new session, check the contents of the folder outside R. Okay, now we'll make a small short demo for RStudio. So let me have an RStudio, then so you please download RStudio, and is the screen visible?
Yes, sir. Yes, sir, visible.
Okay, thank you. Now, this is the RStudio. In this RStudio, what you do, there are basically four files are there. Okay, sorry. Now, are you able to see? So these are the major four windows are there. Top two and bottom two. So let me say top left. So top left is completely for your files. So I can start my R code here. I can do that. And I can use my presentation. So this is my presentation, statistical foundation using R programming. So your PPTs also is available here. And next here, this is my class notes, in fact. So this is the class notes which I have given. Now I can see that, say, for example, if I use this, I will get my. Okay, so this is my class notes. Are you able to see this? Right, thank you. Okay, so what I'll do, so these are available. In fact, these are available in the cloud. All my students practice iteration method, ninja transition method, and all those methods. Okay, now what I do, I don't want to this. So therefore, what I told, this particular thing is a web page, or I can also use it as a say, suppose they want to take a printout, then I can convert them into, sorry, it is not like that. So therefore, I can PDF, and I can run it as a Word also. I can export it. So therefore, you can integrate with the Word, and you can web page and PDF. And next, so therefore, top left is the window which you can use, and you can run various codes also. So for example, if you insert a code, so these are all the things which are available. Say you can run R code, you can use bash or D3, I don't know, whatever, and you can run Python code, you can run CPP, so and you can run a SQL command. So therefore you can also input the command. Say for example, okay, now this is the R code is there, and next not only R code, and you will see that this is the LaTeX code is also there. So this is the LaTeX code. LaTeX code. So you can add all the codes, and this is the markdown. So therefore top left is the one which is useful for that. And you can import the data file. So what are all the files you can do that? So you can write the new file. So these are the files. You can do that, and next you can start a new project. The project is nothing but a directory where you have with a specific purpose, specific task. So for example, I'm using the environmental project like the air quality project. So I can do that. I can use the medical diagnostic project like so the prediction, COVID prediction project. So like that I can add many projects, and I can, and these are the this one. Okay, next. Top left. Now let us moving to the down. So that is top down. This is your console, just like you have R console. So this is the console where you can instantly check your this one. Any command is there, new command is there. Simply you can check here. So for example, I can say I'll just say curve, and I want to do the curve of sin x of in the limits -3 to +3. Now I want to check whether it is working or not. Yes, it is working. So let me check whether it is working or not. So margins too large. So therefore still it is working because it can't run in a window. Okay, next. So therefore top down is nothing but your this one console, just like your console, control L. Next again, and what is there you want to see. Say for example, what are the values, and whether it is a vector or a data frame, or otherwise it is a plot, and this data is a matrix, and this data is a matrix. So like this. So you can remove, suppose if you want to clean all the environment, here you have got a what broomstick. So you can simply wipe out. So therefore now your environment will be free. Now there is nothing in your R environment. Next. So this is top. And next you can also import data. Here you can create your link to the database also. Okay. So these are all the things which you can data. Next. Okay. Next, top down. So down, let me check what is down. So let me minimize this array, this window, so that okay. So here this is the history. So history means once you run it, all these commands in the source will go to the console. Whatever it comes into the console, it will be maintained in the history. Okay. Now I can do one thing. I have a choice whether, say for example, I have a choice here. Now let me take oh, okay. Let me take this one. Now I want this command is there. Now I have an option if this command is a very good command, I can move it to the source or I can move it to the console. Say suppose I want to make it a console, then it is running. So it has come to the console. I think I've seen it. Okay. Next, suppose if I want to move it to the source, then I can move it to source. So this is what is my source. So here it has come. So likewise, so therefore all these commands, either you can place them into your source, you can add them to source, or otherwise you can move them and test it in the console. So that is your history. So history also you can clean it. History also you can save it. I can give a different name to it because everybody keeps disturbing my history. So I just want to store it, this today's history. I'll put them 29th June for my project history. So therefore I can say, suppose I will say that it will ask for the name. Then I can give this is my 29th June I'm work. So please keep this history. So next time I can load it directly. So therefore I can remove all this. Okay, I can remove all this. So therefore my now there is no history is there, no environment is there. Now this is my files. So these are my files. That means this is my project directory. So this is my project directory. So in this project directory, okay, this is my project directory. Next, these are my plots. So suppose earlier I made a plot for sine. So all the plots will appear here. And this is my connection. So I can establish a connection. Or what is that? Create a new connection. Okay, so this is the ODBC connectivity. You can directly pull the data from the database. Next, the next one is called the packages. This is very important for you. So these are the packages. So most of the statistical analysis, you can write the code which I'm telling like this, but there are for a specific task, a lot of packages are available, and all these packages you can what you can build it as a package and you can install the packages. So you have to go to the top tools and install packages. You can install the package and next check for package updates. So now it will immediately check in the CRAN, comprehensive R network, any updates are available, then these packages will be updated. And next, suppose if you are having your package in Git, then you also do that version control. Next. Okay, so therefore these are all the packages. Next, this is the help. You can simply type anything and you will get that. So simply you type, then immediately it will give all the comments. Simply with example also it will get. So you will get an example and here, and you can take this as an example and you can copy it and you can start your new R here, R script. Okay, so here you can run it and you can execute it. So I'm executing it. So executing is R. So therefore it is executing. You see that in the console it is executing. So if I like it, I'll just copy it into my project. Otherwise, I'll just ignore it. So what I'll do, I don't want to save it. So this is how you take the help from the RStudio and the viewer. Okay, so this is what is. It is also called IDE, integrated development environment. So you can develop it as a package also. Okay, all your functions, all your objects, all your help nodes, everything will go into a package, and that package you can place it in a cloud where anybody can download it and they can use it and they can give feedback. Is it right? You need some break. Hello?
Sir, we are giving.
Shall we give or not? So break for 5 minutes. Okay. Okay. So please, we'll take a break for 5 minutes, and immediately after 5 minutes, I will tell you what is how to work with collapse. So very important. So please don't miss it. Okay. So we'll break. Thank you. Oh, very, very happy statistics day. Oh, yeah, I remember. In fact, the entire credit goes to you. You have scheduled so that it has coincided with the very important the birth anniversary of Indian famous statistician P.C. Mahalanobis. Praful Chandra Mahalanobis is the founder of the Indian Statistical Institute. Ah, so I should be thankful to you, madam, and I wish you all a very happy Statistics Day. And we'll meet immediately after 5 minutes, right? Shall we start?
Yes, sir.
Okay, right. Yeah. Back to presentation. Next. So next type of working is the R Studio and the Jupyter Notebook. Say in many machine learning works, you should always have your code, output, notes, everything. It should be side by side. Immediately, you must be able to, because I have code in one window and I have got output in another window. So that type of thing will becomes very difficult. In fact, once you run it, then immediately you must be able to, and um, it should be able to run. So Jupyter is one such IDE which is mainly used for this one. It is Python. Python will use, so that is what you can do. You can integrate with the code and you can integrate with the text and you can integrate with plots. So therefore, this is a notebook environment, and this notebook, and you can mount it to this one, and you can integrate with the Git. Everything will be only one notebook will be there. Once anybody runs it, then they'll be able to test it very easily, and you can make he can modify it. So Jupyter Notebook is one such environment where you can use mainly for machine learning projects. Okay, next. So R code can be run in Python environment by loading the library, and Google provides cloud-based laboratory to many coding platforms. Say you can run R, you can run Julia, you can run Python, you can, okay. So likewise, you can run many things in Google Colaboratory, Colabs. Okay. I will place it in the this one. I think where you will get it. I think I don't know whether you'll be able to get or not. Okay. Okay. This is, where do I get the chart? Okay. So what I'll do, I'll just share it on the WhatsApp so that you can send it to the others when that is not possible. Okay. So now, so therefore, where is it? Okay. So this is the command which you use in the browser. So that is HTTP collab this one, and you can start R notebook here. Okay. So how do you do that? So simply if I leave this site, okay, okay. Now I can start this. So this is how I can it will start. This is the Google Colab. what is the advantage of this is you can, okay. Now, so this is the collab. So don't get worried, even though it is IPyNB, it is not a Python notebook. You can do R here because so you can do the R and you can add the code. So it's already by default, it is in the code only, and you can add the text also. Okay, so let me, okay. So this is the text. So here you can add the text like, say for example, I want to, okay. So, so therefore, so this is, okay. So shift immediately you can run that command. Now here I can use A is equal to 5 and B is equal to 6. Oh, you cannot see this because if I want to show you and I just want to, I want to show you in notebook, edit. Okay. Okay, you can also do that notebook. See, so these are all the things which you have got. This one, Python 3 and R. You can use the others also, right? Okay. Next. Now I can. Oh, I will open it in playground mode so that it will be very easy for you. So therefore, A is equal to 5, B is equal to 6. Now I want print A plus B plus B. Now it is running. So therefore, you will see that it will give you some processor also, some space also it will give. Okay, some memory it will allocate for us, and it is connected. Now it is running. See, that is this is how you can run. Okay, so you can run the code like this. So and say next. Afterwards, there are some many data files are there, and say for example, if you are running, so there are to give a training on statistical models, lot of built-in data sets are available. Now the data sets, you want the data sets, so simply run and let us see what are all the data files available. Now you will see that. So how do you execute that? Data, open bracket and close bracket. Then here are the list of data files which are available. Say the first one is air passengers data set, and next this is BJ sales. Say for example, if you want to predict a model for the sales, then BJ sales is there, and BOD, biochemical oxygen demand, and next my goodness. Am I audible? Am I audible? Hello? Am I audible?
Yes, sir.
Acha, acha, okay, okay, right. Okay, so next, so now let us say there is one data file which is called motor cars. So that is, this is the data set, and I will run it shift and enter. You will get that complete data set here. Now, are you able to see the screen?
Yes, sir.
Okay, right. Thank you. Thank you. Okay. Now, so therefore, this is the data set which you are having. Now, if you want to say, I'll just give a name to this because every time I can't use that. So I'll say that this is df is equal to, I call it is df is equal to, I'll say df. So that is df stands for my data frame. Now, since I have named it, there is no output because it is already there in df. Now I want to see what is my header. For the data file, you have got my df header. So this is my header. So I'll just remove this. Now this is my header. Header means what happens? It has got some rows and Mazda and Datsun. So these are all the various cars. And how many are there? Only top 6 rows are there, followed by the column names. So miles per gallon, cylinder, displacement, horsepower, draught, weight, cubic, VS, AM, how many number of gears, and carburetor type. Okay, so these are all the specifications of an automobile. Now this is called a data frame. This is called a data frame. So what is a data frame? A data frame is a two-dimensional structure where it is not a matrix. In matrix, all the elements are of same type. Whereas in data frame, the columns can be of different type. Columns means, say, for example, the miles per gallon, it is a numeric vector. And cylinders, a discrete numeric vector. And whether Vs is equal to 1 or 0, it is a logical variable. Or gears, a discrete. So like that, each and every and another, the row names are there. They are text. So therefore, that is what is called a data frame. So a data frame is a two-dimensional arrangement of data where each column can be of different type. Okay, so the data column has got the names. So let me say what are the names. Names are nothing but names, and I need not type completely. I can select this names. So this is my names. And next I can say df. Now let me see what are the names. Names is equal to, then you will see that. So this is my names. So all these are all the names. Now I want my row names. Okay, these are my row names. Now I just want to remove the row names. So how do I do that? I will say that row names of my data frame is equal to none. Null. Then what happens? Then we'll remove. Now let me see whether it is removed or not. Head of df. So then you will see that now there is no row names. So therefore it is only 1 to 6. And I can also remove the column names also. Now if I remove the column names, what happens? Names of my df is equal to null. Okay. Again, I will see what is the now you see there are no column names, there are no row names. It is just like looking like a matrix. Now again, I don't want this because at least I need the columns. All the columns are called the features. So therefore, what I'll do, I will again execute this, and now this is my new one. And next, I remove the column names, row names null. Then I got okay. Now, so these are called what? These are called um, what features. So there are different names for this. These are called either the features, or among the features, if you are building a model, then it is called the predictors, or okay, or you can also call explanatory variables. Various things are there. Just let me go. Okay, where is that? This one. Hmm. Oh, so this is the collab. Okay, and now. So these are all the various ways we can work with the Google Colabs, right? Now what we do, so we'll start with the variables. Variables means a named data location is called a variable, and you can use uppercase letters, lowercase letters, and space is not allowed. So we use underscore. So customer name raw, customer is 45, payment received 300, fully paid false, number of visits 10. So this small thing is called a code snippet. So this is the small, it is called code snippet. Okay, next. Now, what are all the data types are there? Number of visits is an integer, and payment received is a numeric floating. And next, customer name is a character, and fully paid is logical with yes or no. So you must be able to do the analysis for every type of variable. Okay, next. Now, how do we create vectors? We'll create the vectors. A vectors is nothing but an ordered collection of elements and are the strings or characters of the same type. Okay. Next, vectors are created by assignment. So simply you can say sales is equal to day is equal to, or alternatively, you can other way. First one is the name, second one is the object. Assign command is first one is the name and second one is the object. Similarly, vector is equal to, or otherwise this is another type of assignment is vector. Every vector has got two mode. So mode is nothing but the mode is nothing but the it all depends upon the quantity which is holding. Say for example, whether it is a character mode, whether it is a numeric mode or floating mode or like that. And length is number of elements are there. Say for example, 2, 8, 3. Now what is the length? Length is equal to 3. So this is A, then length is equal to 3. So mode will give you the data type and length will give you the number of elements. Now if you want sales 3 gives you the Next. So for all the functions, they have got small brackets. Now, what about the square brackets? Square brackets is only for subsetting. Square bracket is only for subsetting. So subsetting means A2 is equal to 8. Now, what is A3? So this square bracket is only for subsetting. So sales 3 will give you the sales on the third position, and sales 4 plus sales 5 add the sales of fourth day and fifth day, and minus 1.2. You have to subtract first two elements, and what is the mode of the sales is numeric, and what is the length of the sales 6 days, and as character sales will change the numeric to character. So as character is one thing which will forcibly change the mode, and is character is a question, logical, yes if it is true or false. Next, when you are making the data points, you must be able to generate the sequences. Say, for example, I want to generate the sequence of 1 to 100. So I will say that is equal to 1 to 100. So simply with single this thing I can generate, or otherwise so this will generate 1, 2, 3, etc. etc. Now suppose I want to generate 1 to 100 with skipping 2 at a time. So it will generate first 1 plus 2, 3, 3 plus 2, 5, 5 plus 2, 7, etc. up to 99. Okay, so this is how you can generate the sequences. And next, you can generate the sequences by minus also. So I can start with 99 to 1 with minus. So this is how you can generate the sequence. So you can copy this and run it and see whether it is working or not. Next, once you have the sequence, that means you are generating the axis. Then you can plot it. Okay, you can plot it. So the plot will come like this. Okay, next. So sequences are useful for that. Matrix. So matrix is a rectangular arrangement of data, and they are called rows and columns. And the length of the vector should be factored into number of rows into number of columns. Otherwise, that does not exist. So the matrix is generated by, first one is a vector, and how many rows are required, and whether to fill the matrix by row. By row means this is by row, and then by column. So therefore, by row true means first element will be second element, third element. Once this row is over, it will move to second row. So therefore, how do you generate a matrix? You can generate a matrix of any vector of, and then specify the number of rows, and by row is equal to true or false. It can be also. It all depends upon how you want to fill up the matrix. So once the matrix is obtained, so this is the output of the matrix. Now let us see, I'll just remove them. Next, then this matrix, I can convert them into table also. Say for example, this matrix, I can convert them as a data frame. So the data frame, so that means I can give the I can give them what I can give them some names. Say I can give them some branch names. Okay. So these are the branches and these are the cities. So I can give them, say this is CSE, ECE, mechanical or electrical, that are some branches. And here you can see this is JNTU, AU, SVU or like that. So I can move them. Okay. So this is how you can. So therefore I can name them. Then this will become a data frame. Or if you are using some chi-square analysis, you'll be dealing with the tables. So everything can be possible either directly reading from an Excel file or otherwise you can generate the matrix. So this is the matrix. Next. And these are the product of matrix. So there are different types of products of matrix are available. So that means element wise product is called A star B. So therefore it is very important if you are using star, if you are using star means element wise. It is not the matrix wise. So therefore you can use star. So this is how you can create the So therefore that product will become 5, 12, and next you have got 21 and 32. So this is A star B. And whereas this one is matrix multiplication, row column multiplication. So in the row column multiplication, that is equal to how much? So this is the row and this is the column. So therefore this is 5 plus 14, this is 19. And next this is 6 plus 16, 22. And next this is 15 plus 21, 15, 35, 36. And next this is 18 plus 32, 18 plus 32, 42, 42 plus 8, 50. So this is what is row column multiplication. So this is A percentage star percentage B. So and outer product and inner product and TA will give you the transpose. So these are all we can do when you are doing with the matrices and solving the matrices. Yeah. So solving the linear algebra you can do. So for example, if you want the diagonal, then you will get to the diagonal and you can find the eigenvalues. You can find this solve means it will find the inverse. Eigen A means eigenvalues and all these things you can do very easily. See, for example, I have got a matrix and I want to solve the inverse of A, then I will get this matrix. The next one is called the creating data frames. Data frames means a data frame is equal to, so it starts with data dot frame. This is how you call the function and keyword key value pair. So key value means you have to get name. This is name is equal to value. So whether is equal to surname is this one, sales is equal to, then immediately a data frame will be created. So the name will become the column name, value will become the vector, and these vectors should be of the same length. Then only a data frame is created. And you can create the arrays and everything. So we don't want to do that right now. Now, so how do we now you have a problem how to load the data. So how to load the data? You can read the data by very convenient way is read.csv. read.csv, and here you have to give the file name, and here you have to give whether header is equal to true. Whether if header is equal to false, then what happens? There is no header. So then it will give without names. So whether the column names can be taken from the first row or not, it is the matter. Okay. So header is equal to false. True. Next. Now, once it is loaded into the environment, then all these variables are made available to you free. Okay. Now these are the functions. So function means you can create a function with arguments. Say for example, I want to create a function. So this is function. You have to give the argument, and here you can give, if it is a small, then you can give here itself. If it is a large, then you can give here. So you have to give this is say x square minus x minus 1. Then this defines a function, but you have to name it, otherwise you can't call it. So everything should be named. So I'll just name it, and this is my name. So this is my name. I can call f. So this is how you can define a function. Okay. Next. Now, so with this input, immediately I think hardly any time is left. Now I'll go to some models, like how you are going to use this for your predictive models, machine learning models. Now, so we start with suppose you have got a data frame. The data frame is of say this is x1, x2, x, etc., xp, and there is one target variable is there. Okay, so these are called features. So these are called features. And this is called target. Now, so this I can write it as x. It is a vector, so x bar. Now, what I want y from the values of x. Now, what is the use of this is, say for example, so I want to build this. So I input this data and I build this. So this is my data. Now, suppose I build a model. That model is something like, so I can develop a model like this is equal to, say I will get this is B0 plus B1 X1, etc., plus BP XP. So this is the model. Okay, so once this is the model, then what I do, I will use the new data. So this model is developed, then I can use further new data. Is coming? Hello? Am I audible?
Yes, sir.
Okay. Right. Next. So this is the new data. So what I do, so this is called the model. Say for example, for the sales data is there, the sales will see that whether it is a rainy day or otherwise whether it is a festival, yes or no, and whether any functions are taking place or what is the happening month or not. Then I want to predict the sales. So this, so therefore, so this is type of. So here these models are very important. What we have to do, you have to build the model and you have to apply the model with the new data, and then you will put the model to use. And if it is not satisfactory, then what you do, again you have to train with more. You have to train with more, and you keep on training and build a model. Okay, so in this, a linear regression is a very fundamental model. So in linear regression, what happens? I'll just will go to what is linear regression. So, so therefore, our linear regression model is this one. Y is a target, and this is the very general model. Now, with R, you'll be able to create such model, and you can train the model, and you can validate the model, and next you can apply, okay, very easily. So this is one such model, and where Y is called the response variable, dependent variable, or it is also called target variable. And next, these variables are called control variables, regressors, independent variables, or they're also called explanatory variables. Explanatory variables are they're also called predictors. Predictors. Okay, so these functions are base functions, and so this is the advanced regressions. So which we are not very much interested. Okay, next, what I start with only the y. So y is the target variable. So in this target variable, some y's are will take values of any numeric value. And some y's will take any value but 0, 1, 2, 3 discrete values. And some y's will take only either 0 or 1. Now I'll tell you what are the instances where you will get 0, 1. So for example, if these are all the features, whether typhoid yes or no, and this is whether typhoid yes or no. And next, arrival of number of persons. So how many guests will be turning up? 0, 1, 2, 3, etc. So, or otherwise, what is the weight? How can we predict weight? So these are all different ways. Depending upon this way, we'll be using various regressions. So one regression is called, we use logistic regression. And we get this is linear regression, or this is Poisson regression, or like that. So we start with a linear regression. In linear regression, what happens? All fives are only some polynomials, j, x square, or like that. So therefore, see, This is the data set. Now data air quality means you will get you'll have access. This is the air quality data set is a built-in data set in R. Now if you see head, it will give you only first top 6 rows, but just I made a presentation, so I have pruned the 6th row so that you can't see 6th row. And next, suppose you want to read your own data, then you can see read.csv, and you can see you can give the path to your file in your local system. First, what we do, the data cleaning process, we will see that whether all the data is available or not. And next we will see whether any missing values are there. If missing values are there, what is to be done. And this data, what we do, we divide the data into train data and test data. So in the train data, we will be building the model. So this is the model will be built. And next, then with the testing data, so therefore, so in the training data, you have only X bar. And in the testing data, you have X bar as well as Y. OK, so from the testing data, this model you will get Y hat. Now from this you will get Y hat here. And from this you will get Y here. Now you see, sorry, this is not the bar. OK. So this is the Y. So now you see the difference. So you will get this is the error. Now by minimization, again what you do, you'll be improving the model. So once you improve the model, here we are choosing the variables. So to start with, we do not know how many variables to select. So what are the, how to rank the variables. So that is called the feature engineering. It is called the feature engineering. What feature engineering does is, what are the best features which will be contributing to the maximum variance in the model. Next, model fitting. So once we get that, we have a set of variables which we can use, and type of model we can use, template of a model. Then model fitting is very easy. It is a compression job for the software. It will do that. Next, you have to interpret the results. Now what we do, we will see that there are some statistical tests are there using which you will be telling how reliable is the model is. OK, next, accessing the predictive ability of the model on the test data. OK, next what we do, we will linear regression. In the linear regression, when you start with this small, so linear regression has got assumptions like first y is equal to a constant will be there, so which is called the intercept or the bias term, and whereas this is called the regression. So these are called regression coefficients. And this is called the bias or intercept. And what about epsilon? Epsilon is called the random error. So whatever the, and here this is called the target variable. And this is called the predictor. OK, so therefore this is the model. Once you fit the model, what happens immediately? The final model, it will give the final model is like this. So this is the final model. So in this final model, you have trained this data to, say for example, you have got one data file 1, you have trained it. You get this. Next, you can once you build the model with then you can give this model access to somebody else, then with some dashboard. Then he can add his own data. So therefore, this is data 1, already is trained, and he can add his data 2, and very large data, and he can improve the model. So this model will become refined and will be able to predict accurately, more accurately. Okay. Next. Now, when you use R package, very small command called LM. LM stands for the linear model. So LM stands for the linear model. Okay, and this is the target, and this is the predictor. And here this is tilde is there, similar. So it is, so you have to give, you have to specify the model like this. What is the target variable? What is the predictive value? And this is tilde. And in addition, you can also give the data set here. So here you can also give the data set. Okay, then you get the model. So once that model is there, says suppose this is the data set. I told already there is a built-in data sets are there. So many data sets. So if you want to see what are all the data sets in your installation, simply what you have to do, this is data bracket begin bracket close. So once you execute this command, then you will get all the list of data files and how to use them, everything you will get it. Now data empty cars loads the data set, and next, now what I'm doing, so I'm naming because I want to give my own name. So simply I named it in my name VR data and rename the data set. And what I'm doing here is I want to check whether any non-availability are there. So what I have defined small function here, function fx sum is NA. So if it is NA, if it is true, then I will get that. So I apply on the this one, then you will get all what is NA, nothing is there. So all 32 cases are there. So in this particular data set, 32 values for MPG, cylinders, displacement, draught, weight. So anything is, suppose someone is say 30, then immediately you have to check the missing values and you have to see the policy whether to missing value shall be excluded or not. So how do we use this model? This is LM, this is LM, MPG, weight, data is equal to VR data. So MPG is my target and weight is my predictor. So in this model, where if it is a heavy vehicle, the miles per gallon is less. So therefore, this is how you will get it. So therefore, I fit the model. Once you execute the model, then you will get this. Means this model is equal to 37.285 minus 5.344 into WT. So this minus indicates as the weight increases, the mileage will come down. And what is the contribution? Suppose if I increase the weight by 1 kilo, say it is in tons, isn't it? So therefore, suppose 10 kilos weight is there, 5 kilometers mileage will become, it will be reduced. Okay. And next, this is the constant. So this is how you get the model, very easy. Now, once I plot this data, I type of thing. So this is the weight variable and this is the miles per gallon. So therefore, it is coming down. So this type of thing. For example, if you don't use any predictor variable, such a model is called null model. Null model means this is the model which is called null model. I don't use any predictor. So then this is called the null model. Now what is the model? Once you use this regression model, so what is the error? So actual mileage is here and you are predicting the model. So therefore this is the error. And for this is the error from the negative side, and this is positive side. These are the errors. So then what happens? This null model will be shifted. So this is your alternate model. So this model R has generated for, and the null model, there is a lot of improvement. So therefore, this is how the linear regression is fit to the data. And this is called the summary, and this is the statistics part. Okay. Next. Now this variance is equal to, say, this is your observed y and this is your model. Now this is called MSC, or the mean square error. Oh, sorry, this is the variance of y. So variance of y is equal to variance of the model minus the error. Now, so therefore, if the error and if the variance of the model increases, then it will be able to predict best. So it will be able to predict best if the model variance is very high and residual error is less. Now we have calculated this. Okay. Now I just want to show you. So these are the validations. Immediately, quickly, I want to show you how to do this. Okay. Now let me go back. So this is my model. And so now what I have empty cars data set. So therefore, let me see what is the header of it. So header means I will be able to see. I don't know whether it is. Oh, it is there still. Yes, it is there. Now I just want to see the structure. Suppose I want the structure. I'll simply say structure, str. Strdf means you will get the structure. That means it is just like a describe function similar to Python. In Python pandas data, this one you have got describe. Just like that you have got structure. In the structure, it is a data frame of 32 observations of 11 variables. How many features are there? 11. How many observations are there? 32. Now the first one is a numeric. Second, these are all numeric only. So what are all the values? Decimal places are possible here. These are integer values. So like that. Okay. Now what I want to use? I want to use a new data set. So for example, I just want to use only this one. Say for example, I can write my data frame, use only C. Next, I want weight, and next MPC. So that means in the complete, I have taken only two variables. Now, if I take only two variables, so how do I take the two variables? I have to mention the data frame name. Oh. Okay, I have to find the data frame name and list of variables. Now let me call this is my df. So I replace df1, say. So df1 is my data. Now I just want to see, now my data file is very simple. So that is my head, this is df1. df1 is my simple data. Okay, df1. So in this, I just want to fit the model. So what is the model? So that is, I want to fit the model, linear model. In the linear model, I want to predict what is MPZ, and next what I want to predict weight, and my data set is what? My data set is data is equal to weight. data is equal to df2, df1. df1. Okay. So therefore, now you see, you will get the model. Now you got the same model as 37.285 and 5.344, which is already there in here, which is there already here. 37.285. So likewise, so this is, so you can fit the model very easily. Next, now I just want to plot. Say for example, if I want to plot, what is that? I want to take weight as df1, weight dollar, dollar, what is that? Weight on the weight, and next df1 dollar mpz. Now I just want to plot it. Now you will see. So this is the plot, and this plot I can add the caption and main. So simply I plot it. So immediately I will get the plot here. Okay. So in this plot, what I want to do, I want to add the model also. So that I want to see how it is this one. So I'll get AB line, and so that model I'll give you here. So I'll give a name for it. So I'll give a model. So let us say this is my model. So this is my model, and I'll say this is my model. Now I'll run it. Okay. So therefore, okay. Now this is my model, and next I want to add this model also to the plot. So simply I'll say I'll add. See how you got the model. So this is the model. So if you want the model, you can give the colors, everything. Color is equal to green. This is how you can give this model. Okay. So likewise, so you can add this model. Okay, so now it is, yeah, I think it must be clear how to fit the linear regression model by using Google Colabs. Okay, now you want to verify whether how good is this model. Now, suppose I want to only the coefficients. How to use this model? That means my next task is to my next task is to predict the model. So that means I'll use hash. Okay. Using the model. So how do I use the model? That means I want to predict the model, and next what is that? I want the predict the model, that is using the predict. So immediately you are getting the values. These are the values. So these are the values which you are getting. Now I just want to keep side by side. So I want to create a new data frame. So for example, I can create one df1 dollar my predict. That means this is the model prediction. So model prediction is equal to, now I just want my prediction, I'll keep here. I just name it, that's all. So that means whatever the result comes here, I just add them as a data, this one, so that there is no output at all. Now I will see what is my DF1. Let us see what is my head, which is DF1. Then I will see my data frame. So first one is the weight, and the second one is the males, and the next one is the prediction. So you got the prediction also. Okay. Now suppose you ask me, there are two vehicles are there, which is having some 2.1 and 4.8. Can you please predict the mileage? Now I'll see that this is new data. New n data. N data is equal to, I want my data frame. Data dot frame. Data dot frame and weight is equal to C. I have got two models are there. New models have come, but with different weights. So 3.2 and next 4.1. And I just want to predict it. So predict only mileage for these two. Then I got this new data is come. Now I want to say predict, and next my model is model. This is my model, predict my model, and next new data is equal to my end data. That's all. So once I get it, then I will get what is that mileage. So this is my mileage. So this is, see, I think you will be able to see that. So the higher the weight, so 4.1 is having less mileage. So in this particular session, what I'm able to tell you about how to create a linear model from an empty cars data set and how to plot it. And this is your total data frame, and you have verified the data frame, and how to overview the data frame by the structure. And next, what is the how to pick up the selected variables. So I select weight and MPG, and I now choose the MPG as a target variable, and I fit a linear model. I name the model as MODEL, and next the model is here and coefficients, and next and I can plot them, and I can overlay the plot, and I can see this. And next, using the model, how to use the model for the new data. So this is for the old data, and this is for the new data. So new data is here. New data. In somebody will ask you, I have got two cars with weights. This one, can you please predict? Then this is how it is predicting. Okay, is it okay? Any more questions? And next, now suppose you want to see the model. Now you want to overview the model. Statistically, you can validate the model. So how do you validate the model? Um, so this is the model summary, and it will give you everything. That means this model, um, many hundreds of models are generated, from which it has been found that the weight, the estimate will be lying in this. So this is what is the p values. So probability will be calculated. If it is 3 stars are coming, means very small values, means these are significantly contributing to the variance of the model. They're very important. Okay. Next. Now suppose confidence intervals also it will give. These are the confidence intervals. So left side so therefore, so it is equivalent to any model where the intercept is lying between 33.45 to 41 point. So now, so therefore 37 lines in this. So therefore this is good model. Similarly, the weight is also from minus 6 to minus 4 to this one. Okay. So the weight is equal to minus 5. Why weight is equal to minus 5? Because if the weight increases, the mileage will come down. So it has got a negative effect on the mileage. So that is a minus. So any more questions? Many things are there, linear model. The next one is the logistic regression. So because the logistic regression, you cannot use the linear regression assumes that y is a numeric variable lying between minus 1 infinity to plus infinity. But in logistic regression, you have got 1, 0. So there are many cases are there in log which uses logistic regression. So one is whether the typhoid is yes or no, whether the customer buys or not, whether the student is admitted or not. So these are all the things where the target variable is a binary variable. In such case, we can predict by using logistic model. I think it is time. In the same way, you can also you can use the logistic model also. You can use a very simple command. Use the function called GLM, which stands for generalized linear model, where the target variable is a binary variable and the predictors. And if you want the constant, you have to type +1, otherwise no. Next, you have to input the data file here and you have to specify binomial and the link function is the logit. Then you'll be able to get the model. Okay. So is it okay? Hello?
Yes, sir.
So I can, in 5 minutes, I can ask some questions. I can answer. When do they give the exam, madam? Oh, acha, acha, okay, okay, right. Okay. So I okay, no more questions. So thank you very much. Thank you all of thank you. Okay. Okay, thank you.